Thank you.
Tracy Van Brakle, who is actually the expert member of technical staff at AT&T Labs, and she's also CTO for RAN. Can you go to the next slide? I'll do that, okay. So I had the distinct pleasure of working with Tracy when I was in AT&T Labs. So among various professional achievement, she also has been leading many of the NSF and DoD projects. Most recently, she is a PI for this NTIA project ACCUR, Accelerating Compatibility, Commercialization of Open RAN Deployment. So this is a very right topic, and what Jillian just mentioned, Tracy is probably going to say how things are getting done on the ground with help from many operators, vendors, SDOs, and research organization. So with that, Tracy, I know you're planning to come today, but you couldn't come, unfortunately, but please take it over. I got 20 minutes for your presentation.
Sure. I'll share my slides.
Thanks.
Hopefully you can see my slides.
Yeah, go to the first slide. Yeah, it's coming up.
Okay, and let me close this.
So I'll give you 5 minutes warning, Tracy, just to keep on time. Thanks.
Well, first thing I want to point out is when I'll be talking about this work, like a lot of the work that's being presented today, is very much a beneficiary of and based upon the O-RAN Alliance miracle that Chi Lin and other co-founders of O-RAN pulled off. It really was a miracle. Chi Lin, I remember back in 2019 when O-RAN was first established. I'm glad you mentioned the first PlugFest in 2019. Your team, I think, ran it in China, and I ran its counterpart in North America. And today I'm here to talk about, and again, it's funny that you on slide 19, item number 1, AI, machine learning, 3GPP, O-RAN, flow and topics. This is I'll be talking about a sub-branch of artificial intelligence planning, which of course, machine learning is another sub-branch. And this is, an artificial intelligence planning enabled, scenario. It actually started out as a proof of concept demonstration in one of the O-RAN PlugFests that Chilean was talking about. It was an attempt, and still is an attempt, to exercise, O-RAN interfaces and experiment, hopefully advance O-RAN abstractions, O-RAN architecture. As you can see, this project has quite a few O-RAN member participants: AT&T, Ericsson, High Street Technologies, Fujitsu. Rutgers, of course, is one of the first O-RAN testing and open testing integration centers in North America, partnering with Columbia University and NYU. They call themselves Cosmos. They're also a National Science Foundation platform, Advanced Wireless Research Initiative, Indoor Outdoor City Scale Testbed. We've got, University of California, Riverside, Howard University involved now. So as you can see, the seeds that were planted by Shilin and others in the O-RAN Alliance are starting to grow. And we're very fortunate for the support from the National Science Foundation to co-fund some of this work. So the first, what the notion here is, and this started out as a thought exercise. What can we do? What you see here this is New Jersey. This is Middletown, New Jersey, not far from where I work and where Hurricane Sandy devastated the network resources of both hypothetical operator A. You'll see on the left, we have representation of a service management orchestration framework, of course, as defined within the ORAN Alliance and realized within ORAN software community. And on the right-hand side, you see operator B. And when everything's fine, each of their access points, overlapping coverage, normal operation, and there's no need to implement any multi-operator orchestration or cooperation during normal operation. However, in the event of Hurricane Sandy, and this is actually a very realistic scenario and not the only scenario of its type, when whatever it is, whether it's a hurricane or, God forbid, an asteroid, you see that the X's mark access points that are damaged or destroyed within both operator A and operator B networks. And anybody who's familiar with this area knows who operator A and operator B happen to be. AT&T is one of them. So what if, in addition to all the benefits that each single operator would derive from ORAN architecture, service management, the orchestration framework, let's pretend that, of course, back then this would not have been possible, that this is, an open RAN, or at least hybrid open RAN. If there were this notion of a higher level SMO of SMOs, we're calling it MOSMO, multi-operator service management orchestration framework, that could identify whether it's access points or subtending network resources. Let's say it's, DUs, RUs that survived and would be available for resource pooling, basically transforming these two non-cooperative networks into a single cooperative network. Again, this is an area with overlapping coverage, such that the bits that survive could be sliced end to end and optimized, again, via the ORAN SMO and ORAN SMO components. And maybe, if this works as we hope it would, restoration could occur within minutes or hours. Back in the day when Hurricane Sandy hit, restoration took days. So that's the thought behind this. Started as a proof of concept demonstration back in, I don't remember how far back, 2020, I think, 2021. And now again, with support from the National Science Foundation, they like the concept. They want to know, how do we get beyond concept to the point that we can actually, go from a low fidelity prototype to something that operators can use. And the goal here, the vision is, and the name of this project is Indigo. And the vision is that, Indigo could actually augment existing 3GPP-based 5G roaming agreements, and it has the potential of overcoming limitations of some of the emerging RAN sharing approaches, for example, MORAN and MOCAN. Indigo, by the way, is intelligent networks designed and integrated for globalized operations. Obviously, we're using 5G and ORAN concepts. Everything we're looking to do is intended to advance the standards and the specifications in both 3GPP and ORAN. And primarily we're looking to let first responder teams operate through 5G networks, regardless of these civilian disasters, with security resilience and quality of experience that can be intelligently controlled end to end. And here, when we're talking about intelligence, we're talking about a form of explainable artificial intelligence, an AI planner, which, oh, by the way, as Cheelan mentioned, I'm with James Lee and Irfan Ghouri, one of the co-chairs of the open source focus group. This happens to be open source. This AI planner that I'll spend most of my time talking about is based on SHOP 3, Simple Hierarchical Ordered Planner. So if this does what we hope it will do, Indigo would be able to integrate and orchestrate across 5G, next G, actually all G, if we do this comprehensively, which is going to be difficult and it may never happen. All G meaning that there will be first responders in parts of the world where there is no 5G. And of course, we have to take a hybrid approach. It would be great if the miraculously 5G RAN became Open RAN. That will take time. So we have to deal with mixed environments. We're looking to achieve in a mixed environment flow through provisioning of network type non-cooperative. And that's, of course, non-cooperative doesn't mean we don't get along. It means that we don't have any ability to, we meaning operators, to make any changes within each other's networks. So AT&T and Verizon, we collaborate very closely in O-RAN and also in anytime there's a disaster, but our networks are basically non-cooperative. How do we, in the event of a civilian disaster, bring them together as a single unified cooperative network capable of restoration and restoration in less under 3 minutes, I'm sorry. And beyond that, the ability to dynamically optimize end-to-end quality of experience, resilience, security, which cannot be done easily in view of how 5G roaming agreements are implemented or exist today. So at a high level, and this is obviously a kind of a big animal picture, you see you've got multi-operator service management orchestration framework. We realize that in order to expand multi-operator orchestration capabilities, we would benefit from importing some of the APIs from Telemanagement Forum. So, the multi-operator service management orchestration framework that would exist only in the event of a civilian disaster will communicate with single operator service management orchestration frameworks via these APIs. And the notion is that in the event of a disaster, the single operator SMOs would upload topology, topography, lots of network information that would allow the AI planner to make some decisions. Again, this is not with machine learning. It could be expanded and enhanced with machine learning, but right now we're just talking about an AI planner, white box, explainable. You'll see a few relevant R apps. This notion of a mission planner, let's say the mission is to, rescue, typhoon victims in the middle of pick the ocean of your choice. The Resilience R app is working with a multi-path configurator. Let's say whoever's directing this hypothetical mission wants super duper resilience, wants the ability to choose up to 4 diverse paths, whether those are 3GPP, satellite, non-3GPP, or something else. And we say diverse, we mean loosely, devoid of, that each of these paths has no single points of failure in common. And then, of course, the security RAP, everybody's learning that there are actually advantages. You can actually have more visibility and there's more you can accomplish from a security perspective. You could develop, a form of dynamic application security testing as an RAP, and you could run it at user-definable intervals. Again, this is not something that's going to exist this year or next year, but it will evolve as it has since the idea, first came about back in 2021. So I'm not going to talk about all of these pieces. I'm going to focus mostly on the AI planner. So before going to the deeper dive into the AI planner, you know, a few points about, and this slide says competition. It really shouldn't. This is more about cooperation during the unthinkable. And there will always be, I mean, I'm with AT&T, and all operators want to retain, our autonomy and our commercial advantages and key differentiators. But, there are humanitarian missions that will happen all too frequently, and we're going to have to cooperate. So overcoming the limitations of single operator approach, single operator networks are vulnerable to infrastructure damage. What we saw Hurricane Sandy, and more recently, this is a recent graph regarding a public safety network outage.
Tracy, you have 5 minutes.
We don't want to be in a position that we've got, 3 operators and, with overlapping coverage. And if we had some intelligent method of, pooling their resources, we could restore wireless communications in minutes, not in hours or days. We could overcome network congestion. We could dynamically share spectrum in a way that is difficult or not possible as in a single operator approach. So let me quickly go to,
4 minutes.
I'm going to go to the real quick. There'll be more, you'll see more of this demonstrated at, yes, Chilin, we're going to continue our tradition of supporting the ORAN Plugfest every year, twice a year. You'll see a demo of this at the next ORAN Plugfest. To finish, AI planning is a subfield of artificial intelligence, has nothing to do with machine learning. Machine learning is also a subfield. You could bring the two together. It's how do we use an AI planner, which has the view, it's an agent acting in the world. It has a goal, and the goal is to solve a problem, to deliver a plan that consists of a sequence of actions that can be understood by a human being. Human being can say, yes, execute the plan, no, modify the plan, or alternatively, I'm giving you new information, come up with a new plan. So I'm going to stop now because I don't want to use up more time than, I think I've already used up more time than I was allotted. But again, Chilin and everybody else who's contributed to the ORAN Alliance, this is based on your work, our work, and I'll be demonstrating more of it as it evolves. Thank you.
Thank you, Chilin. Let's give a big round of applause for our speakers. Hey, Tracy, this is a great complimentary talk to what Chilin spoke about, and I'm so happy to see there has been a really renewed efforts all around from the government side, from the operators, vendors. You're going to hear from Scott next, and how things are going on the experimental side. And as you know, Tracy, IEEE has a 5G 6G innovation testbed, and thank you for inviting us to join the force, and whatever way we can help, being a catalyst for this Open RAN deployment, we'll be happy to do that. Folks who would like to ask questions, please put that in the chat box, and I'll request the speakers to answer the questions. Running out of time.